Good evening.
Hello, everyone.
Good evening.
Good evening,
Good
sir.
evening, everyone. Good evening. Okay. Let's just start. Okay, na? So, capacitor part we were discussing na last. Okay. Right. Charan, Lokesh, both of you are there. Right. Okay. Let's just start now. अब चाहिए. Okay. Right. Okay. Let's just start now. चार्जर या वो लगा दो चार्जर लेके. Okay, let's just start now. Okay, so we were in the parallel plate capacitor. We have capacitance calculated, isn't it? And we have also discussed what is the effect of dielectric. Okay, effect of dielectric on the capacitance. That is what we have also calculated in the question, isn't it? Please tell me, is this part clear? Up to this part is clear to everyone?
Yes, sir.
Right. So here, what we did, we introduced the dielectric, right? And whenever we introduce the dielectric, what happens? The permittivity of the medium will change, isn't it? And if the permittivity is changing, that means what? The capacitance will change. Because capacitance depends on what factor? Capacitance depends on area of the plate, separation between the plate, and one more thing is the medium between the plates of the capacitor. Okay, so these are the factors on which the capacitance of a circuit, capacitance of a conductor depends. Is that clear? Now, if we keep the battery connected and then we introduce the dielectric in the space filled by the vacuum, then what will happen? This is what we have discussed in the last class. Okay, capacitance will increase, isn't it? Because medium permittivity, now it will become k times of epsilon naught. Okay, so capacitance got increased, charge got increased, energy got increased, and electric field remain constant. Is that clear? So let's discuss one more example here, and then we will go for the next part. Okay, in the next example, what is given to us? In the next example, what is given to us? That here you have seen the battery was still connected, है ना? When we introduced the dielectric in the space field, है ना? Please tell me. In the last question, we discussed what we did. We kept the battery connected and introduced the dielectric. Today, we are just going to make a slight difference. We will introduce the dielectric after disconnecting the battery. Okay, meaning is what? Let's say there is a capacitor here. Okay, that capacitor was initially connected with a what? A battery of voltage V or EMF E. Okay, and its capacitance is how much? Something C. So what will happen? Is this capacitor will get charged? Please tell me. Please tell me. Is this capacitor is getting charged, isn't it? And how much will be the charge on this capacitor? C into E will be the charge on the capacitor. The question says what? Once the capacitor get charged, okay? Question says what? Once the capacitor get fully charged, okay? Once capacitor gets fully charged, Okay, once capacitor gets fully charged, it is disconnected from battery. It is disconnected from battery and a dielectric slab of constant K. Okay, dielectric slab will have na dielectric constant K is introduced. And here what I am doing, whatever the space between the capacitor plate is there, na, I am going to fill the space completely with the dielectric. Later we will learn that if I fill that space partially with dielectric and partially with vacuum, then what will happen? Okay. But here what we are doing in these two questions, earlier question also, in this question also, we are going to fill the space what? Completely. Okay. Dielectric slab of constant K is introduced. Okay. Dielectric slab of constant K is introduced. Okay. Introduce. Okay. Now you have to again find what is the charge on the capacitor now. Okay, find what is the charge on the capacitor now. Second thing, what is the capacitance now. Okay, third thing, what is the energy stored. Okay, what is the energy stored in the capacitor, that also we have to answer in the question. And the electric field. Okay, energy stored we should calculate, and then the electric field in the region. Can you tell me the difference in the last question and this question? In the last question, we introduced the dielectric, but we kept the battery still in connection. Okay, but now what we are doing, we are going to introduce the dielectric after disconnecting the capacitor plate from the battery. Okay, so please tell me what are these value before introduction of dielectric and after the introduction of dielectric, what are these value? Okay, please tell me how much it is coming. Will you try?
The charge will remain same, but the voltage will change.
Yes, charge will remain constant and what will change?
Voltage,
Capa-
voltage.
yes, voltage will change, capacitance will change, energy stored will change, electric field will change, isn't it? But what will remain constant in this example? The charge will remain constant. Okay, so that is what we should learn it in this question. Okay, so let's write again a table. This is what before introducing the dielectric, and this is what after introduction of dielectric. Okay, let's write the values now. Before introduction of dielectric, what was the capacitance? Epsilon naught A by D. After, what will be the capacitance? K times of epsilon naught A by D. That is about capacitance. Charge. Initially, is the charge initially was epsilon naught A by D into EMF. And what will be the final charge? Is the final charge is also same? Isn't it? Because if you uh, disconnect it from the battery, the charge has nowhere to go, isn't it? So whatever is the charge on the capacitor plate got accumulated before dielectric was introduced, the same charge will remain on the capacitor plate. It will not change at all. Next, if I write energy stored, what I should use it for energy stored? So can I write it? Energy stored will become Q square by 2C. And final energy stored, how much it will become then? Q square by 2. And can I say capacitance become K times of C? So you see that capacitance got increased here. Charge remain constant and energy got decreased in this question. Okay. What about the field? Initially the field will be how much? Please tell me. Initially the field will be how much? The field initially you can write it sigma by epsilon naught. And what will be the field now? Sigma by epsilon of medium. Is that clear? Because the medium got changed, है ना? Medium permittivity got changed, isn't it? So that's why initially the field in the space was sigma by epsilon naught. And now the electric field in the space is sigma by epsilon of that medium after the introduction. Understood? And epsilon of medium is what? Epsilon of medium is k times of epsilon naught. So you can see that the field also got decreased. Understood? So sometimes they can ask you like that, what will happen with the capacitance, increase, decrease. Okay. Please tell me, clear up to this?
Yes.
So
Yes,
this is the parallel plate capacitor. Now we understood what is the energy stored in the capacitor, isn't it? What will be the energy stored in a parallel plate capacitor, the electric field in that region of a parallel plate capacitor, isn't it? Now, how do we find out if only partially the dielectric is introduced? Understand the question? What we have to do, if I introduce the dielectric partially, partially means what? Let's say this separation is D. What I did when I introduced the slab in that space, I did not fill the complete D space with the dielectric. What I did, let's say D by 3 I filled with dielectric, and remaining portion I kept it as it is the vacuum. Or I filled two slab of different dielectric. Again, some part filled with dielectric, some part is still vacuum, some part with another dielectric, isn't it? So if I have to find out what will be the equivalent capacitance after partially filling with dielectric, then we should learn first thing is called connection of capacitors. Connection of capacitor means what? There will be two type of connection of capacitor possible. Okay, right? What are the two type of connection possible? Series connection and the
series.
parallel connection. Okay, so let's discuss first that one, connection of capacitor, okay, or you can also call it combination of capacitors. Okay, so we have two type of combination possible. Okay, one is called series combination, okay, and other one is called what? The parallel combination of the capacitor. Now tell me, how can I identify that this particular combination of capacitors are series? Please tell me, how can we identify the particular given capacitors are connected in series? So
When the
if I see and find, tell me what is same?
when the current flown through them.
Yeah, if the current flowing through, if all the capacitors are same, we will call it series. But in capacitor, what happened? We never calculate what is the current through it. We are more interested about what is the charge flowing, charge accumulated on the capacitor. Okay, so what you said, current is same, that is correct, but that will be more appropriate if I tell it for the resistors. In series combination of capacitor, isn't it better I should say the charge is same? Because if same current is flowing through both the capacitor, so I can say same charge will be also accumulating on both the capacitor, isn't it? So in the series combination, what we will say, charge on, if two or more than two capacitors are connected in series, they will have what? The same charge on each. And in parallel, can you tell me what will be same?
Voltage will.
Yes, voltage difference or potential difference will be what? Difference is same for two or more than two capacitors. Okay, if two or more than two capacitors are connected in such a way that they have the same potential difference, then we will call these are connected in parallel. So how do we calculate the C equivalent in series and parallel? So in series, if I show you a simple diagram of connection of capacitor in series, this one, like that, many are there, है ना? Let's say these capacitors are connected in a circuit like this. So you see that whatever current will flow, same will flow through each capacitor, isn't it? Because there is no distribution of the current happening, no distribution of charge happening. So all the capacitor will have what? The same charge. Let's say this is C1, this is C2, this is C3. Like that, some more capacitors are there. So this is called the series combination. So in the series, 1 by C equivalent will come 1 by C1 plus 1 by C2 plus 1 by C3, like that. It is just opposite of what? The resistor formula. But identification is same. Identification of series and parallel is same whether it is a resistor or capacitor. But the formula of series and formula of parallel in case of capacitor and resistor will be what? Exactly opposite of each other. Okay. So series, what is the same we have known? Series charge is going to be what? Same on each capacitor. Next, parallel combination, what will happen? So parallel combination, we will say potential difference or voltage difference between the two or more than two capacitors are equal. Then we will call that these capacitors are connected in parallel to each other. Okay. So what will happen here? Delta V is going to be what? The same. Potential difference is going to be what? The same. Okay. Let's draw the circuit like this. This is the C1. Let's say there is another one, C2. There is another one given, something C3, right? And this is connected with a battery of some EMF E. Now look at these capacitors. This is C1, this is C2, this is C3. Okay. You see, are they connected across same potential? Isn't it? Because what is the potential here? Same is here, same is here. Same way these points are having what? The same potential. So you see, C1, C2, and C3. These three capacitors, potential difference across these three capacitors are equal. That means they are connected across same voltage difference or same potential difference. So this one will be called as what? The parallel combination. So C equivalent in parallel, how much it will come? C equivalent in parallel will come C1 plus C2 plus C3 plus C4, like that. This is called the parallel combination of the capacitor. Understood? Please tell me, up to this part is clear?
Yes, sir. Clear.
Yes, sir.
Clear? So this is called the series and parallel combination of the capacitor. Okay. In series, charge will be same, and in parallel, potential difference is going to be what? Same. Okay. So now let's learn about what will happen. Then we will discuss some examples on that. What will happen if I fill the dielectric partially? If I fill the dielectric what? Partially. Okay. Like, let's say there is a situation given, because once you understand what is the series and parallel combination formula, then you can solve this partially filling of dielectric also. Okay. Capacitor filled partially with dielectric. Okay. Let's say there is a capacitor here given. Okay. Little bit bigger diagram I am drawing. Area of the plate is A here, same area of the plate A here. Separation between these two plates is D. And right now it is what? Vacuum. Okay. What we did, we filled a slab. Area is same. Okay. The slab I am filling now, that also has the same area. and its dielectric constant is K1 and its thickness is T1. Understood? Then I introduce another dielectric slab. What is the dielectric constant of this one? K2, and thickness is what? T2. Now they are asking in the question, if it is completely filled with a single dielectric, then the capacitance will come just what? K into epsilon naught A by D. But what is the problem here? The complete D space is not filled by a same dielectric. That is the one problem. Another problem is what? It's not even completely filled. There is some space still left as vacuum. So if you want to calculate the equivalent capacitance of this one, you can redraw the circuit like this. This is the one. I will make one capacitor like this. Then I will make one more capacitor like this. And then I will make one more capacitor like this. You know what are these capacitors? This is a capacitor. Let's call it C1, C2, and C3. Can you tell me what are these C1, C2, C3? C1 is the capacitor which is formed of plate area A, medium as K1, and thickness is T1. So here I will consider the thickness means the separation between the plate as T1. Understood? C2 is another capacitor. But what is the medium in the C2 capacitor? K2 medium. C2 capacitor, what medium is there? In the C2 capacitor, the medium is, okay, what is the medium? The medium is the, okay, C2 capacitor, the medium is the K2. And C3, whatever is the remaining left. So please tell me what will be C1 for us? Can I write it? C1 will be equal to K1 epsilon naught A by T1. Please check it. C1 capacitor is what? It is formed by a plate area, thickness T1, dielectric K1 has thickness T1, na? So separation between the plate T1, area of the plate A, and dielectric constant is K1. Can you tell me what I will write the C2 value? Please tell me what I will write the C2 value. C2 value we will write it K2 epsilon naught A by T2. And what is the C3 we will write it? So C3 we will write it. C3 means what? The remaining portion, na? The remaining portion to vacuum is there. So epsilon naught A by, can I write it? D minus T1 plus T2. Can we write it like this? Out of total D, T1 is occupied by K1, T2 is occupied by K2. The remaining place is occupied by the vacuum. Now look at that. How these three capacitors are connected? These three capacitors are connected in series. So I will write it C equivalent as 1 by C1 plus 1 by C2 plus 1 by C3. Because in series combination of resistors, C equivalent will come 1 by C1 plus 1 by C2 plus 1 by C3. Now let's replace the value. 1 by, what is the C1? K1 epsilon naught A. Can I write it here? T1 plus C2 means K2 epsilon naught A, T2 will come. C3 epsilon naught A, right? D minus T1 plus T2 we got it, isn't it? You see, 1 by C equivalent, will it come? Check it. 1 by epsilon naught A, can I take it common? 1 by epsilon naught A we have taken common. This is T1 by K1 plus T2 by K2 plus D minus T1 plus. So please tell me what is the C equivalent finally we got it. Is the C equivalent finally we are getting epsilon naught A divided by T1 by K1, T2 by K2, and remaining part is what? D minus T1 plus T2. And y of a vacuum is 1. Dielectric constant of a vacuum is what? 1. You see that? Do you understand this C equivalent thing? If the dielectric is what? Partially filled. It is not occupying the complete space. Rather, what it is doing? It is occupying partially the space of the that vacuum part. Understood? Partially, it is occupying the space between the plates of the capacitor. Please tell me, clear up to this? You see that T1 thickness of dielectric constant K1. So you see that epsilon naught A, so as it is what we will get it in the standard equation. A standard equation of equivalent capacitance is what? Epsilon naught A by separation. But here separation, what happened? T1 separation is K1 thickness, K1 dielectric. So T1 by K1. T2 separation, K2 dielectric. So T2 by K2. And D minus T1 plus T2, that is of what dielectric? 1 dielectric. So that means that's why we have written it 1 in this denominator. Understood? There will be one more way we can introduce the dielectric between the plates. Here what I have done, I have introduced the dielectric in such a way that area of the dielectric है ना, is same as the area of the plate. If I introduce the dielectric in this way, see that I'm going to introduce dielectric like this. Can you check it? What I have done here? Here, K1 dielectric, I have filled with A1 area. Understood? Total plate area was A, but it is introduced in such a way that A1 area is occupied by K1 dielectric. Remaining A2 area is occupied by what? Remaining what area? A2 area is occupied by another medium. Let's call it as the K2. Okay. Here what is common in both the cases? Here the separation D is common in that. How you will find the C equivalent? So in this case, what we will do it? We will make, can I make it something like this? The upper one capacitor, the lower one, another capacitor. And how these two are connected? These two are connected in parallel. This is C1, the blue color is C2. Can you tell me what is the C2? K2, A2, है ना? K2 epsilon naught A2 by D. And what is the C1 we have? K1 epsilon naught A1 by D. So what is the C equivalent will finally come? The C equivalent finally will come C1 plus C2 because these two are connected in parallel to each other. So K1 epsilon naught A1 by D plus K2 epsilon naught A2 by D. Please tell me, simple, understood? Epsilon naught by D, you can take it common. K1 A1 plus K2 A2 will be our answer. So this is the equivalent capacity if you introduce the dielectric in such a way that the separation is same for both of the dielectric, but they are occupying different area. They are occupying what? They are occupying the different area. So in that case, what will happen? They will behave like the parallel combination. Okay. And we will calculate the C equivalent using the parallel combination of capacitors. So please tell me Are you clear about the series and parallel combination? There is third way also, partially series, partially parallel. Means series and parallel simultaneous combination. But that will very rarely the series and parallel, either series or parallel. Matlab dielectric is introduced in such a way that either these dielectrics are in series, means capacitor formed by these dielectrics are in series, or capacitance formed by these dielectrics are in parallel. Okay, these are the two cases we discussed. Please tell me, clear up to this?
Yes, sir.
Right. Now let's find out what is the C equivalent in 2-3 examples. Okay. Let's discuss about few examples of calculation of equivalent capacitance. Okay. We have equivalent resistance also calculation and a series and parallel combination of resistor, which will be our topic from the next chapter. Okay. So right now let's first focus on the series and parallel combination of the capacitance. Okay. Let's say an example is given. This is the one capacitance. This is the A. This is the B. Like this it is given to us. Not a very difficult one. Check it. All the capacitance are given. Okay. Let's see. This is given C. This is given C. This is given 2C. This is given 2C. Okay. The question they are asking, find equivalent capacitance. Okay. Find equivalent capacitance. And whenever they will ask equivalent capacitance, they will definitely mention the terminal. Okay, na? They will definitely mention the terminal. Terminal means what? Across which terminal you want to calculate the equivalent capacitance. Okay, the find equivalent capacitance between A and B. Understood? Chali, first solve this one, then I will add one more part of this question. Little bit knowledge of. Yeah, please tell me.
They have to consider jump one.
Yeah, your voice is not coming 100%. Can you just speak a little bit closer?
We have to take some junction point and do it.
Right now, in equivalent capacitance calculation.
Yes.
No, here it won't be needed. Na? Just check it. If you look at that, you see this capacitor and this capacitor. Are these two connected in parallel?
Okay.
See that? These 2 points and these 2 points. Right? So these two capacitance are connected in what? Parallel to each other. So this C and this C are connected in parallel. So I can make it a single one, isn't it? Means this circuit will look like this. Asha, one more thing, please keep in mind. Whenever you calculate equivalent capacitance or resistance, don't eliminate the terminal about which you have to calculate the equivalent capacitance or resistance. Okay, always calculate C equivalent or R equivalent about that terminal last. Like here I have to calculate between A and B. So don't eliminate A and B. Matlab, don't think that this one and this one are in series. No, no, no. Don't do that. First of all, come from the outside and reach the A and B point. Understood? So you see, this C and this C together, can it be replaced by one capacitance? And this C and C, can it be replaced by one capacitance? And C and C in parallel, how much it will become? 2C it will become. This other capacitor 2C, this other capacitor 2C. Now check it here. Are these two capacitors connected in series? है ना? Check it. These two are connected in series. Earlier, these two were connected in parallel. Okay. If these two are connected in series, how my circuit will look further? So A and B, I have to calculate. I am keeping it intact. And look at here, 2C, 2C in series. So how much 2C, 2C in series will come? So you can write it now. In series, what is the formula for series? 1 by 2C plus 1 by 2C. So it will come 2 by 2C. That means C equivalent will come C. So that means this 2C and 2C, you can replace it by C. This is the terminal A and this is the terminal B. Now look at that again. How these two are connected. This is A, so this is also A. This is B, so this is also B. Isn't it these two again become the parallel combination? The 2C and 2C is in parallel. So finally the equivalent capacitance, how much we got it? 3C we got it. Understood this question? Please tell me.
Yes, sir. And
Yes, sir.
Please tell all of you got this one. Boli Lokesh.
sir, got it.
Right. Right. So sometime what will happen? We will get a question where some capacitors will be connected in series, some capacitor will be connected in parallel. Okay. And then we have to find the capacitance of that arrangement. Now, one thing I am going to ask you, I'm going to take the same question diagram one more time. And this time, what I will do, I will connect a battery. I calculated C equivalent across A and B. Na? I have calculated C equivalent across A and B. So, what I am going to do in this question, C. Was it my circuit? Please tell me. These four capacitors given are C, C, 2C, 2C, है ना? This is C given, this is C given, this is 2C given, this is 2C given. Okay. A question gave what? There is a battery of what voltage? V voltage is connected here. Now the question they are asking what? The question is asking from me, find charge on each capacitor. Understood? Find charge on each capacitor. How much charge is on each capacitor we have? That's what they are asking in the question. Find charge on each capacitor. So tell me what will happen. First of all, tell me what is the total charge coming through the battery? So total charge coming through the battery will be C equivalent into battery voltage. What is the C equivalent we have calculated in our question? See, you have connected the battery across A and B, na? Right? So please keep in mind whenever you connect a battery and they ask you the charge and all those things, find equivalent across the battery terminal. Understood? Always find the equivalent across the battery terminal. I'm just using the word equivalent, not the capacitance, because same concept we have to apply for the capacitance, same concept we have to apply it for the resistance. Okay. So C equivalent is 3C, voltage is V. So that means what is the total charge which is flowing through the battery? So total charge which is flowing through this battery in this circuit is 3CV. Understood the first part of the question? Please tell me. If the question asks what is the total charge supplied by the battery, my answer will be 3CV. Okay. Now, tell me what is the capacitance of this entire branch? This entire branch capacitance, is it C? Check it now. Now be comfortable. This is C, this is C. Right? The 2C will come. Then
Yeah.
2C and 2C in series, C will come.
C will
This
come.
entire branch has C, and the lower branch has what? Lower branch is 2C. Look at that blue
Total
branch
C.
and black branch. Are they connected in parallel? And you know, charge on a capacitor is C into delta V. Now you see, if they are connected in parallel, see that if the connection is parallel, if they are parallel, can I say that delta V is same? So that means, can I say charge will become proportional to capacitance? More the capacitance, more the charge it will accumulate. So look at the blue branch has C capacitance and the lower branch has 2C capacitance. So can I say their capacitance is in the ratio of 1:2? They are connected in parallel. So can I say their charge distribution is also going to be in the ratio of 1:2? So this branch has lower capacitance. This branch will have lower charge. How can you distribute 1:2? So can I say this branch is going to have, I have to distribute 3 CV into 1:2 ratio. So 1 plus 2 into 1, isn't it? That will be one fraction. 3 CV by 1 plus 2 into 2, that will be other fraction, isn't it? So that will come 3 CV by 3, that is CV will come, another one 2 CV will come. Matlab this 3 CV charge I have distributed at the junction in what ratio? In the ratio of 1:2. So that means this branch will have CV charge, this branch will have what charge? 2 CV charge. Now the charge will reach this junction. Understood? One distribution already happened at this junction in the two branches. Now please tell me how much charge is reaching here, this junction, yellow junction? CV. Can I say that is going to distribute in equal proportion here? Why I am saying equal proportion? Because equal capacitance. So CV charge, if I distribute it equal proportion, will it become CV by 2 and will it become CV by 2? Please tell me, do you understand charge on each capacitor now? Please tell me, if I mark these capacitor, if I give name to this capacitor, capacitor number, let's call it X, capacitor number Y, capacitor number Z, capacitor number W. Please tell me, what is the charge on capacitor X? CV by 2. Charge on capacitor Y, CV by 2. On Z, CV. On W, 2 CV. Understood? So these are the charges on individual capacitors. Is that clear? And instead of charge, they can also ask you in the question, what is the energy stored? Isn't it? बोलिए. Tell me. Instead of charge, they can also ask you in the question, what is the energy stored in these one? So now you know the charges on each capacitor, isn't it? If I know what is the charge on each capacitor, can we find out what will be the energy stored in each capacitor? Please tell me, what is the energy stored in a capacitor? Energy stored in a capacitor can be written as half C into potential difference across the capacitor, or it can be also written as Q square by 2C. Whichever is known to us, that we should use it in the problem to find out the energy stored. If charge is known, use it Q square by 2C. If potential difference across capacitor is known, let's use it half C potential difference square. So please tell me, do you understand how to calculate equivalent capacitance and how do we calculate the charge and energy stored? or potential difference across the capacitor? Please tell me. Or if the dielectric is partially filled with different type of dielectric, how do you calculate it? Please tell me. Clear this one? Right?
Yes,
Yes,
sir.
sir.
Right. Sometimes the shape of capacitor will be different. Shape of capacitor will be different means what? Instead of capacitor being parallel plate capacitor, they will give us as the spherical capacitor. What is the difference in parallel plate and a spherical capacitor? The simple difference is what? In the parallel plate capacitor, the conductor plates are plane, plane surface. And in spherical capacitor, what we have? The conductor surface are concentric sphere. Let's say this is one sphere, this is what? Another sphere, right? Inner sphere, let's take it A radius, outer sphere, let's take it B radius, okay? We have given some plus q charge to this one, so minus q charge will come here, है ना? Again plus q charge will come here, isn't it? Due to the induction, okay? Or sometime what they will give, sometime they will simply give you that the outer sphere is grounded, okay? So now tell me, what is the capacitance of this one? So capacitance, if I want to find out, what I will do it, I will write charge divided by potential difference, isn't it? What I will write it, capacitance, we will write it charge divided by potential difference, isn't it? That is the definition of capacitance. If I want to find what is the, and both are conductor, okay na? Please keep in mind, A and B are what kind of a sphere? Conducting a sphere, okay? So if I want the capacitance, I need the potential difference. How do I calculate the potential difference? See, in this reason, what will be electric field at a distance r? Is it going to be k q by r square? And from electric field, how do we find the potential difference? dV equal to minus E dot dr, isn't it? So minus, what is the electric field? kq by r square into dr, isn't it? That is the small potential difference. Total potential difference. See, when small r is equal to A, can I say this point is, let's call it 1, and this point is what? 2. So when small r, matlab distance from center, small r is what? Distance of the point from the this concentric sphere. So when small r is equal to A, can I say potential is V1? When small r is equal to V, what is the potential? V2. So we are getting here V2 minus V1 equal to minus outside, K outside, Q outside, dr by r square integration. That will come how much? Minus 1 by r. Limit is A and B. So we are getting V2 minus V1 equal to, minus also again you can send it outside. It is coming KQ 1 by B minus 1 by A. Understood? Or if you want to calculate V1 minus V2, V1 will be high potential. Na? See that? Why V1 is high potential? Because this is the direction of field in this region. Okay? This is the direction of electric field. And electric field is always from high to low potential. So V1 minus V2 is coming. I have just sent the minus other side. It will come KQ. What is V1 minus V2? Is the V1 minus V2 is delta V. K means 1 by 4 pi epsilon naught. This is Q. You can write it here A into B, and this one will become B minus A. Now you see what is the Q by delta V I am getting, and why I am calculating Q by delta V? I am calculating Q by delta V because Q by delta V is coming 4 pi epsilon naught A into B by B minus A. And actually that is the capacitance. So what is the capacitance of a spherical capacitor of radius A and B? Of radius A and B, that is 4 pi epsilon naught AB by B minus A. AB by B minus A. Okay. So this is concentric sphere. Sometimes they will ask you a single conductor, that is called isolated sphere. Isolated sphere means what? We have a only single conductor. So how can it form that? In that case, the other capacitor plate is considered where? At infinity. Means one radius, inner radius we consider R, outer radius we consider infinity. So delta V, how much it will come then? It will again come 1 by 4 pi epsilon naught q. One radius is R, other radius is infinity. So now if you again calculate it, q divided by delta V, it is coming 4 pi epsilon naught R. So this is called what? The capacitance of an isolated sphere. मतलब a single sphere is behaving like what? A capacitor of what capacitance? 4 pi epsilon naught R. So please tell me whatever we have discussed, do you understand up to this or not? Please tell me. Please tell me, Charan, Lokesh.
Sir. Understood, sir.
Yes, sir.
Right. So next part, what we have is the electrodynamics part also we have. So now in the next class, we will discuss about the cylindrical capacitor, right? Three type of capacitor we have: parallel plate, spherical, and cylindrical. So the third type, small part is there. What will be the cylindrical capacitance? And after that, we'll go to the electrodynamics part from the electrostatic. Okay. Some properties of conductor we will discuss. Okay, is that clear?
Yes, sir.
Yes.
Right. Okay. So let's meet it tomorrow, same time. Okay, and we'll continue from here.
Okay, sir. Thank you.
Thank you so much. Take care.